In the figure, a slab of mass M1 equals 42 kilograms rests on a frictionless floor, and a block of mass M2 equals 9 kilograms rests on top of the slab. Between block and slab, the coefficient of static friction is 0.6, and the coefficient of kinetic friction is 0.4. A horizontal force F of magnitude 106 newtons begins to pull directly on the block as shown. In unit vector notation, what are the resulting accelerations of A, the block, and B, the slab? Let's start by making this diagram a good amount bigger. Okay, and let's label everything. So, M2, M1, M2. M1 is the slab, which is 42 kilograms. Okay? M2 is the block, which is 9 kilograms. Our force vector is going to be pointing to the left at a magnitude of 106 newtons. So, let's draw a free body diagram of the block. So the block, okay, the block M2, which is 9 kilograms, okay, is pulled this way to the left by a force of 106 newtons. It's pulled to the right by the friction force. Okay, now we're given both the static friction force and the kinetic friction force. The static friction coefficient and the coefficient of kinetic friction. The reason for this is we want to know whether or not this force of 106 newtons is enough to get the block moving. So the first thing we need to figure out is the static friction. How much force do we need to get the block moving? So that's going to be the normal force of the block, okay? The normal force of the block multiplied by the coefficient of static friction, okay? The normal force of the block is simply mg times the coefficient of static friction, which is 0.6, which is equal to 9 times 9.8 times 0.6. And we get the answer of 52.92 newtons, okay? So, if our pulling force of 106 newtons is greater than this, then the block will be moving. Now, 106 newtons is indeed greater than these 52 newtons, which means that the block is going to be moving. So now let's figure out the friction force of the block moving, which in this case, instead of using the normal force times the coefficient of static friction, we use the coefficient of kinetic friction. So exact same thing as before, 9 kilograms times 9.8 times, in this case, 0.4, which is going to give us 9 times 9.8 times 0.4, 35.28 newtons. So our friction force is pulling us to the right by 35.28 newtons. Let me draw this arrow smaller so that it's clear which one's winning out. So the net force on this block is going to be left. Okay, it's going to be left by 106 minus 35.28 newtons. And that'll get us 70.72 newtons. Okay, 70.72 newtons. So, we know that F equals ma, Newton's second law. Our force is 70.72. Our mass is 9 kilograms. Our A is what we need to find. So to find A, we just divide by 9. Okay, and our A is going to end up being 7.85777, repeating with an 8 at the end. Now, if you are in answering this for homework in certain random generator programs, it may want you to make this negative because it's moving to the left. Now for part B. Oh, last thing we need is we need to make this into unit vector notation. Okay, there is only movement along the x-axis. There is no movement along the y. There's no movement along the z. So in unit vector notation would be negative 7.85777778 ij, or I, excuse me, plus 0j plus 0z. Or what is it, ij? I think it's just two-dimensional. Okay? And now for part B. What are the resulting accelerations of the block and B, the slab? Okay, so in terms of the slab, okay, the only force that we have acting upon it is the friction force between the block and the slab. We know what that friction force is. That friction force is 35.28 newtons. 35.28 newtons. So the force acted upon the slab is 35.28 newtons, which is equal to its mass times its acceleration. In this case, its mass is 42 kilograms times A. So we divide both sides by 42, and we get A equals 35.28 divided by 42, 0.84. And again, depending on if you're doing this for homework and submitting it on a program that does auto-generated numbers, it may want you to do negative 0.84 meters per second squared because we're moving to the left. Okay, and this is the answer for part B. If we want this in unit vector notation, it would be negative 0.84 I plus 0j, because there is no movement in the y direction or the z direction. Okay, and that's it. That's the answers.